two types. Number one, we have zero repeating decimals. Zero repeating decimals, and then we have non-zero repeating decimals. For zero repeating decimals, an example can be like 0.2. And then it means that you have many zeros coming. Okay, this is a zero repeating decimal. But you can also write this as 0.2. Then another example can be like 1.2, let's say 4. So these are some examples of zero repeating decimals. Then non-zero repeating decimals, we have like, let's say 0.2 repeating. It means that 2 is continuing many times. It cannot end. We can have like, let's say 1.67, 67 repeating. We can have, let's say, like 0.456, implying that 456 is repeating endlessly. So these are some examples of non-zero repeating decimals. Okay. So now we are going to see how to write repeating decimals as fractions. Let's have example number 1. Please, you can mute your speaker, please. Let's have example number 1. Let's say, write the following decimals as fractions. Write the following decimals as fractions. Let's have A as 0.4. B, we have 0.1257. Let's have C as 2.5. We have D as 3.7. And let's have E as 1.45. Okay, so when you look at the numbers that we have in example 1, they are all zero repeating decimals. These are zero repeating decimals. So let's see how to write these kind of decimals as fractions. Let's get the solutions. So for part A, we have 0.4. And we all know that 0.4 as a fraction means 4 out of 10. Is that okay? So if we have 4 out of 10, we can write this in simplest form if we divide by 2, 4 divided by 2 and 10 divided by 2. So you find that 4 divided by 2, you'll get 2, and 10 divided by 2, you'll get 5. So you get 2 out of 5. So it implies that 0.4 as a decimal can be written as a fraction as 2 out of 5. I hope that is very, very okay. Let's get part B. We have got 0.1257. So if we have 0.1257, then we will have 1257 out of, now we consider 1 and then we count how many digits do we have after the decimal point. 1, 2, 3, 4. So it means that we will have 4 zeros. 1, 2, 3, and 4. So that's how we write that as a decimal. In part C, we have 2.5. To write 2.5 as a decimal, we will write 2 plus 0.5, that is 0.5, which is 5 out of 10. And we know that 5 out of 10 can be written in the simplest form. If we divide 5 by 5 and 10 by 5. So it implies that we will get 2 plus 5 divided by 5 is 1, and 10 divided by 5 is 2. So we have 2 plus a half. So as a fraction, we get 2 and a half. So this means that 2.5 is equal to 2 and a half when it is written as a fraction. Let's look at part D. So for part D, we have 3.7. 3.7, it can be 3 plus 7 out of 10. So because 7 out of 10 is already in simplest form, in other words, there is no factor that we can divide by 7 and 10. 7 and 10 do not have a common factor to divide with in order to write it in the simplest form. So this means that 7 out of 10 is already in simplest form. So our final answer will be 3 and 7 out of 10. Okay. And finally, we look at part E, where we have 1.45. So this will be 1 plus 45 out of 100. And you can see that 45 out of 100, we can write it in simplest form. If we divide by 5 and 100 by 5, so we will get 1 plus 45 divided by 5, we get 9. And 100 divided by 5, we get 20. So we get 1 and 9 out of 20. So that's how we write that as a fraction. Is that okay?
Okay, teacher.
Okay. So now let's look at example number 2. This one, we are going to write non-zero repeating decimals as fractions. Let's have it as example number 2. Write the following, and let's just have it as write 0.7 repeating as a fraction. Okay, so the method of changing non-zero repeating decimals to fraction is different from that one of changing zero repeating decimals to fractions. So, and this is the way how we do it. So let's have the solution. So we say that let n equal to 0.7 repeating. And we know that 0.7 repeating can also be written as 0.777 and many sevens. So we call this equation number 1. Okay, now you can see that we have only one digit that is repeating itself. You can see that it will continue to be 7, 7, 7, 7. One digit repeating itself. So since it is one digit repeating itself, we are going to multiply on both sides by 10 so that we will remain with the integer only. So you can see that we will get the next step, we will multiply both sides of the equation 1 by 10. We are multiplying by 10 because it is only one digit repeating. So if we multiply by 10, 10 times n, we will get 10n. And 10 times 0.7 repeating, it means that the decimal point will skip one digit. So instead, we will have 7.777 repeating. And we can call this equation number 2. So in the next step, we are going to subtract equation 1 from equation 2. Subtract equation 1 from equation 2. So this means that we will have equation 2 is 10n equals 7.777 repeating. And equation 1 is n equals 0.777 repeating. So we will have 10n minus n is equal to 7.777 repeating minus 0.777 repeating. 10n minus 1n will remain with 9n. And if we get 7.777 repeating minus 0.777 repeating, this is 0, 0, 0 point, and this is 7. So we get 7. So this means that 9n equals 7. And then when we divide on both sides by 9, we are going to get n equals 7 out of 9. So it means that, therefore, the decimal 0.7 repeating is the same as 7 out of 10 as a fraction. I hope this is okay. Okay, so let's get another example. And for this example, we are going to have when we have 2 digits repeating after the decimal point. Let's have this as example number 2. Sorry, example number 3. Let's have right 0.42 repeating as a fraction. So we are having 0.42 with 42 repeating. So it's like we have 0.424242 repeating. So this is what we need to write as a fraction. So we will say that let n, like what we did in example 2, let n equal to 0.42 repeating. But remember, 0.42 with 42 repeating is the same as 0.424242 repeating endlessly. And we can call this equation number 1. Now, remember in example 2, we had only 1 digit repeating itself after the decimal point. But for this one, we have 2 digits repeating. So since we have 2 digits repeating, we are going to multiply by 100 on both sides. Note this, if you have 1 digit repeating, like 0.3 repeating, you are going to multiply by 10. But then if you have 2 digits repeating, you are going to multiply by 100. So you need to note that very well. So for this one, we are going to multiply by 100 on both sides because we are having 2 digits after the decimal point repeating. So it means that we are going to multiply by 100 on both sides. So if we multiply by 100, so we get n times 100, then we will get 100n. it is equal to, when we get 100 times 0.4242 repeating, this decimal point will skip 2 digits. So it means that we will have 42.424242 repeating. And we can call this equation number 2. Okay, so in our next step, we will subtract equation 1 from equation 2. Subtract equation 1 from equation 2. So this means that we will have equation 2 as 100n. Then we are going to subtract their equation 1, which is n there. Equation 2, we have 42.424242 repeating. Minus equation 1, we have 0.424242 repeating. Okay, so if we get 42.424242 and 0.424242 minus 0.00000.2 and 4. So you see that we get 42. So this means that in our next step, we will have 100n minus 1n. You will remain with 99n. So this will give us 42. So if we divide on both sides by 99, so we remain with n equaling 42 out of 99. But 42 out of 99, we can write this in simplest form. When we write that in simplest form, we can divide 42 by 3 to get 14 and 99 by 3 to get 33. So this means that n is equal to 14 out of 33. So therefore, 0.42 repeating is equal to 14 out of 33. That is when it is written as a fraction. I hope that is understood. Now, let us get example number 4. This time we will have an example when we have 3 digits repeating after the decimal point. Let's have that as example number 4. Example number 4. Let us have write 0.348. 348 with 348 repeating as a fraction. Remember, if I have 0.348, it means that I have 0.348, 348, 348. To me, that 348 is repeating endlessly. So this is what we need to write as a fraction. So let's have our solution. So like how we did it in example 2 and example 3, we will say that let n equal to 0.348. And remember 348, with 348 repeating, it means that we have 0.348, 348, 348. And we can call this equation number 1. Now, remember like how we said, when we have one digit repeating itself, we will multiply by 10. When we have two digits repeating, we will multiply by 100. So when we have three digits repeating, it means that we will multiply by 1000. So since we have got three digits repeating, we will then multiply by 100. So this means that multiply by 1000 on both sides. So then we are going to have 1000 times n, we get 1000 n. Then we get 0.348 repeating times 1000. A decimal point will skip three digits. So we are going to have 348.348, 348, 348 repeating. And we can call this equation number 2. So you know, in the next step, we have got to subtract equation 1 from equation 2. Subtract equation 1 from equation 2. So when we do that, it means that we are going to get 1000 n minus n. 1000 n minus n is equal to 348.348, 348, 348, repeating, minus 0.348, 348, 348, repeating, from equation number 1. So when we subtract that, when we subtract 348.348, 348, repeating, and we have 0.348, 348, repeating, 0.843. So this means that we are getting 348. So we are getting 999 n is equal to 348. And it means that n is equal to 348 out of 999. But if we write this in simplest form, we divide by 3 to get 3, 3, 3. And when we divide this by 3, we get 1, 1, 6. So this means that we are going to have 116 out of 333. So this means that our decimal, which is 0.348, repeating as a fraction, will be 116 out of 333. So this will be our answer. Okay, so now from what we have seen, you can note that in example number 1, we had 0. In example 1, we had 0.7 repeating, and we saw that this is 7 out of 9. In example number 3, we had 0.42 repeating. We are having 42 out of 99. And in example number 5, we had 0.348, and our answer was 348 out of 999. So from this, you should be noting that actually, when we are having one digit repeating itself, it means that we have 9 as the denominator, and the numerator will be the number repeating itself. So this means that, for instance, if I have 0.2 repeating, it is 2 out of 9. If I have 0.3 repeating, it is the same as 3 out of 9. And for 3 out of 9, you can write it in simplest form to get 1 out of 3. If you have, let's say, 0.8 repeating, it will be 8 out of 9. So one digit repeating gives you 9, and the numerator will be the number repeating. If I have, let's say, 0.61 repeating, it means that I will have 61 out of 2 nines, 9, 9. If I have, let's say, 2.54 repeating, it means that I will have 254 out of 9, 9. You see that we are having 2 nines because 2 digits are repeating. You see? And we can divide this, we can make this, we can reduce this, or we can write it in simplest form if we divide by 3. You see? 5 divided by 3, you get 1, remainder 2. And 24 divided by 3, you will get 18, as 54 divided by 3. And here you get 33. So this is the same as 2 and 18 out of 33. Now, if you have 3 digits repeating, let's say you have 784. It means that you are going to have 784 out of 999. If you have, let's say you have 0.2, you have 0.261. This will be 261 out of 3 nines, 999. Have you understood that, everyone?
Yes.
Okay. So if you have, let's say, 6.5 4, 7, 1. It means that you are going to have 6 and 4, 7, 1 out of 3 nines, 9, 9, 9. I hope that is very well understood.